Pizza's here. Pizza's here. Perfect timing. So welcome to the third annual Pi Day Game Jam. I'm Shannon Liggetfalvey from Axiometric Games, and we're here at the Niagara Falls Innovation Hub. It's great to see each of you, and thank you for making your time to be here. Pizza Man is on his way, so that's great to see. So I'd like to first begin by thanking the Niagara Falls Innovation Hub, Emma, Dan, and the network of support that makes everything possible. Thank you to each of the members. Thank you to each of you for being here. Today is the kickoff event for the Pi Day weekend. March 14th every year is a celebration of the International Day of Mathematics, celebrated around the world, and different educational events take place every year, oftentimes in schools. And so part of the message of what we're going to be looking at here is how math can be expressed through technology, through AI, and through computers. This is the third Pi Day, and so today I'm going to ask you to consider prompt engineering a new experience in the next hour and a half. So if you have a laptop, you can feel free to pull it out. Feel free to pull out your AI of choice. And let's take a look at some of the products that were made last year. So submissions are open from around the world. We're at itch.io/jam/PiJam. And here's a game that was submitted, I believe, from Sweden last year. Let's see if I can crank up the volume. Do we have volume? I'm not getting volume. So we're not going to have volume. That's all right. This was a member here at the hub. Took our theme of the year as literally as possible because it was an eclipse. It was the blood moon eclipse, and he made a circular shooter game. Another submission, just the math book sketch stuff. Some kind of examples. This is what I produced in 2024 and 2025. In 2024, I explored annular matrices. So let's take a quick look at that. Does anyone know where the remote is? Does anyone see a remote? My left is over here.
Are you talking about mouse or?
Yeah, no, it's just because the sound effects are really nice. Hey, Adam's here. All right, great to see you. Thanks for joining us. Yeah, so I was just taking a look at some of the previous projects produced from the Pi Day Game Jam, and this was X-Radar, the outcome of the 2024 Game Jam for me, and it explored the idea of taking a square space and making it a round space. And so here we have the game of Snake, where you're collecting the digits of pi, but the board itself is circular, and it can be, you can sort of see the polygon nature. Here's n equals 3, n equals 4, n equals 5, n equals 6. And then m equals only 1 here, m equals 2, 3, how many different circles are there? And then, navigating around this space, I felt was an interesting and fun experiment. And then in 2025, in the year between 2024 and 2025 was, I think, an AI revolution and the dawn of vibe coding. And so when we did the Pi Day Game Jam last year, we leaned heavily into the capacity of AI in terms of helping make things happen. And in just a couple prompts, we took a simple concept right in front of the group last year, and we said, what if you made a brick breaker around a circle? And it gave me a pretty janky version. And then over the weekend, I put this together. Any sound on that?
We're up to 64.
Laptop sound. Yeah. So here I'm having an output that was the result of natural language, just describing to the AI what outputs I wanted, and then sort of being familiar with the syntax of the coding itself, and in composition between the AI and myself, I produced this over the first week of Pi Day last year. And the theme of last year was Circularum, which is pertaining to circles. It was a curriculum circularum where I introduced a lot of the ideas of pi and mathematics in a basic sense, inspired by the International Day of Mathematics theme of the year, which was play. You can check out those videos to learn more. In 2025, the theme was the penumbra, which was the shadow's edge, and it was just the morning right after the blood moon eclipse, and I thought that was an interesting theme as a metaphor for how AI is removing barriers for learning and development. And so taking these two focuses and smashing them together is essentially what the brand of the Pi Day Game Jam is, which is that software development is applied mathematics and that AI is removing barriers to learning and development. And so the task before you, before each of you or those of you online joining us, is to make a math-inspired game in a week. And let's just quickly scope out the Pi Day Game Jam on the itch page. We have 66 joined. That's the total over the last 3 years. And about 24 joined this year. So we're looking at possibly a new batch of submissions. Here's the submissions feed where you can see the games that were submitted over the previous 2 years. And we're looking forward to seeing the games be submitted this year. March 21st is the deadline. You have 1 week to produce a game and submit it here on our itch page. So what is a game? Ludologist Jesper Juhl suggests that games are rule-based systems with variable, quantifiable outcomes, assigned variables, player effort, and emotional attachment. And Bernard Suits says that games are the voluntary attempt to overcome unnecessary obstacles. And Roger Calloy suggests these 4 main categories of games of competition, games of chance, games of simulation, and games of vertigo. And often these are experienced in composition with each other. Vertigo is like speed. It's like, oh, I'm upside down now. It's like, oh, I'm looking at it from this angle and then that angle quickly. So it's that sort of feeling of being sort of like constantly flipped around in orientation. And, so before I carry on trying to sound too smart, I want to acknowledge that I'm standing on the shoulders of giants, that anything I know is either explicitly or implicitly the result of many very smart people who came before us. And I would reference the stack of books on the table and these names of Euclid and Archimedes, Coxeter, Holden, Mandelbrot, Conway, and Fuller, either directly or indirectly, have had an impact on my thinking and research in geometry and mathematics. And of those who are still among the living, I'd like to thank some who I've had correspondence and friendships with. That'd be Dylan Bond, Albert Carpenter, Kirby Erner, Chandra Kabai, and Tony Burr, who each have provided resources and feedback to me as I've gone through my process of learning and discovery. So thank you to them. And to check them out if you'd like to learn more. So here we are in 2006. We know that pi is 3.1415, etc. However, Archimedes in 250 BC figured it all out by dissecting the circle and found that the ratio of pi is somewhere between 223 over 71 and 22 over 77. So that was an interesting and important thing because they're looking to square the circle. And squaring the circle is something that axiometric games is often trying to do, take a typical conventional game and then triangularize it or put it around an arc. And so I'd like to reveal the theme of the year. The theme of this year is isomorphism, which is a structure preserving one-to-one correspondence between two mathematical systems. As you can see, imagine the position of the dots on the circle compared to the position of the dots on the grid, and understand that from a position of correspondence of the nodes, that they're the same picture. That the territory is or is not the map. That this is a discussion of transformation, distortion, and disorientation. Isomorphism. I'd like you to wrap your head around that as you explore what games you're going to be developing over the week. A little bit of background about my game development. In the age before AI, I have the bona fides of actually having made a few things. And this is one of them. This is Boxio. And I'll show you a quick example of it. But the concept here is rotational symmetry. If you have a octahedron, and then you rotate the octahedron so that the triangle's in the same spot, that's also isometry. Isomorphic. And I made this fun game. Which is playable on my itch page. And you play as a cube and a rhombocuba octahedron as you interact and match up these QR codes, and you try to get your two skids of products to be shipped through at the same time. And you scale the products from boxes to cars to houses to larger items. And so as I've explored this, axiometric games is an exploration of geometry and mathematics. And in order to understand the domain of which I've been studying, an important exercise is of dissection. So imagine a cube and then cut off 3 of the corners. Go ahead. Apparently I can't use the arrow. There you go. So imagine a cube and cut off 3 of the corners and you find a tetrahedron. Cut off the corners there, you find an octahedron, and cut off the corners here, and you find a cube octahedron. And so this dissection of geometry helps us go down to the very core of our cubic space, which is going to be useful for the exploration I've been doing. So what got me into this area of study is sacred geometry. And here's an example, a set of videos from sacred geometry to see if I can speed it up. So I don't know if this is information that's readily available to everyone, or at least that everyone's discussed recently. You can see. So what makes sacred geometry sacred is that it's fundamental, that when you have a circle, you can only stack a certain number of circles around that circle. When you have a sphere, you can only stack a certain number of spheres around that sphere. So the sacred nature is the emergent property of a unified system where all vectors are equal in length. So all spheres being the same size in this case.
So satisfying.
And so what this is a study of the close packing of equal spheres, or the cannonball problem. What is the most efficient way to stack cannonballs? And this geometry is isomorphic with the geometry of a tetrahedron and an octahedron, like so. And you can see here sort of this skewed squish cube. You can imagine that's the 4 sides of a cube, and it's been squished out. That's sort of like a building block. And so I explored it on the direction of building blocks. And I'm just going to show you what that looked like. Oh. And you can see here I made a little space of octahedron, tetrahedron grid that I could go around and build in. But I had a problem. And my problem was that where is 0 on this grid? And the answer is it's off in the corner. And I want 0 to be in the heart of my array, of my grid. So I kept working. And what we're looking to do is develop an isotropic vector matrix. And so I observed that that's possible through many hints and clues from online, and that leads to this shape. And so instead of constructing the objects in the positive space, we're going to look at the space that holds the objects, the negative space, like looking at the table. And so in examining this, we look at the great circles. The great circles are these colored circles that go all the way around the equator of any spherical space. And I got to thinking, if there are 4 circles, as you can see here, is there one curve? Which would mean that you could walk all the way around the edges of the object without repeating a path and covering every path. And so this has been an area of study that I've been carefully looking at in this. And I said, okay, if there's a path through it, we can deconstruct that path. And so I'll show you what I discovered out of that. So what you're looking at is 4 circles that have been fused together into one circle, like this stack of circles. And what's possible is with the right bending, the right sequence of bends, you can unfold it into that structure.
It's like when you peel an orange just right, and then you can...
That's right. And so each of those steps on those turns is a geodesic curve. And those geodesic curves, they exist on the spherical plane. They exist around the world. But you can also take the world and you can put it on a flat surface, a table, put it on a plane. And so you can imagine these are diagrams of the movements that you would take through those steps. And I'll show you what that looks like because I think it's pretty neat. And without belaboring it, I spent a significant amount of time examining this process. And I don't think it'll be necessary to get into it any further here. So let's look at another approach, and that is taking circles and creating intersections here. Again, the theme of isometry is that this shape on the left is this, that the territory and the map correlate because of the 2-dimensional projection in the 3-dimensional shape. Again, there's more projections that demonstrate the theme, which is that the projection you just saw that was oriented in the radius can be unwrapped. Polar coordinates, it's called in Photoshop, as you see there. And there's even more generalizations available. So I wanted to show you an interesting project that I discovered along the way.
Can I just pause you for a second? We're going to switch the mics. It's sort of flat.
So I totally breezed past this slide because it's very dense information. But I do need to show a few examples. So you have in front of you, Vlad, you have in front of you these beads. And pass the little one to Adam. Pass the little one to Adam. Because Adam had an interesting question last time we talked about this. So Adam, how many different ways can you make triangles out of that composition? 6?
So I'm really
Like bend it around and try to take two and make them kiss. And when they kiss, there's only a few ways.
Okay, 3 so far.
Yeah. So if this is 360 degrees and we're bending it into another dimension of space, it can only really do it like this one way. Because if these two
So you don't need
they
like,
can't bend
folding
like
over and then connect
yeah.
the ones that are-
And so that's sort of like one of the fundamental rules, the rule book. You were mentioning like what are the limiting factors of how the construction works when we were discussing before.
Yeah.
And so this stuff blows my mind. I'll try to explain it later. Molecular geometry. All right. So the interesting thing about this process is that these sequences, these pathways, they consist of lefts and rights. So you go right and then left and then left and then right and then right and then left and then right and then left, and you go around the sequence. Those sequences can be converted to binary, and then that binary can be converted to what the computer can interpret and what you see on your screen.
Are you saying that every like yellow is left and orange?
And no, it is not. This was my craft math was done pre-computationally. This is proof without math. When you do it physically, you do it for real first. It just shows that it can be done. And then I started thinking about, I actually used these to track the lefts and the rights. I used these to document it, as you can see, in far too much excruciating detail, documenting all of the lefts and the rights so that I could derive the binaries. And it's the binaries that I'm going to use to pivot to the next point. So the point is that a sequence of numbers can be derived to produce a graphic. Pretty simple. And the same idea I was working with as I walked home, speaking with Gemini. And I said, hey, Gemini, is there such a thing as a nomenclature sequence system to define molecular geometry? And Gemini is like, heck yeah, there sure is. It's called SMILES. I'm like, cool. So I took that information and I brought it over to ChatGPT or Grok, and I said, hey, I want to make is there an API so that I can access all of the molecules that have ever been discovered? Oh, and yes, there is. So so I can derive from an API and prompt the AI to interpret the API. And I'll show you the output of that. And so I want to stress that what I'm showing you right now is maybe 16 to 20 hours of my life, when it would have been that number of weeks to an undergraduate or graduate student 10 years ago. I'm an absolute amateur in molecular geometry, and yet I'm able to now demonstrate by accessing an API. So anyone know any molecular chemistry? You want to name a chemical? Ammonium? Ammonia. There you go. So it's searchable. Why is it searchable? Because I'm super skilled at developing a responsive search engine? No, I just prompted it. And that's part of the underlying message is this. I've learned so much about the subject matter by AI-assisted engineering in exploring these kind of apps. And that's pretty cool. In 2025, I went vibe code crazy and produced all sorts of projects. And it's, I think, important that I highlight a few of them today. So the first one I did, Ant Farm Express, was designed in 3 days to demonstrate that you can make a game in 3 days. And almost entirely vibe coded, other than the arduous process of fixing it when it breaks. So here these ants are going to blow up unless I get them into the hole. And so I'm going to make I have to funnel them. And I happen to already kind of know how to play the game, so I'm just gonna funnel them. There you go. Okay, that's a little annoying. There you go. So you can see how they're now funneled, and you can see the rate of loss has been recovered. And like these little statistics as you play type stuff I've just enjoyed. And actually you can make it more efficient than this. Because when an ant appears, it appears randomly in a random direction. And so you have to you can actually you can make a little, the likelihood that an ant will appear inside of there isn't 0. Oh, and then you pull it down here. Yeah, all right. Ant Farm Express, how fun. One of the things I wanted to emphasize with that is sound design. That when you make a game, it has to have that like annoying little cha-ching, 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 cha-ching. Like the sound effect is what made it 8 times better than if there was no sound effects of what I just showed you. It adds to the satisfaction. In the vibe code domain, I made this little. This is really cool, I think, on mobile. The way the interactions work. Just click and drag to fly around space. I wanted to make this mobile, multiplayer. There was a game I grew up playing called Subspace Continuum, and I wanted to bring back the Magic Man. And so I spent maybe a couple weeks just sort of poking around on this. And what I ended up doing is diverting my attention towards. So what's taking place now is the abandonment of software platforms like Unity, because JavaScript is so much more direct, and developers using AI are now able to return to first principles. Instead of using a package that someone's made and we're just derivatively using, we make packages from scratch, from the AI scratch, in minutes. And so I had a specific use case need, which is that I wanted these ships to have, like, I wanted to make an art maker. And so I made a drawing program. And the drawing program, you can add layers, you can change colors, you can change line thicknesses. It's like a full-on art program. It had exports as SVG and JSON, so that you can use them in your vibe-coded games. You make a game, but you're lacking in graphics. I made a little graphics program, lightweight graphics program, and it only took me 7 weeks. And then I got a job, so I had to stop doing that. But it has a lot of interesting features. I think one of the interesting features here is the cycloid generator is a nice one. You can generate a cycloid. Things like that. Neato. And now I have a few of these little projects. Now, I think the one that's most interesting might be, let's see, this Towngen. Other little projects like exploring topology and river lengths.
Are these real rivers?
Lakes. No, this is just like a generator.
Okay.
Yeah. It's just, there's something to it, being able to have this creative freedom and whipping it up in just a few hours. And I'm going to find the L system. Okay, so there's L system.
Could you use what you just showed us for terrain generation, like automatic terrain generation?
Yeah, that's exactly right. Yeah, that was the idea. My wife was designing a story, and it said that story needs place, and so she needed a map, an underlying map of her fictional world, and I said, let's generate some underlying conditions, like the topology of it, the rivers, because when a city's formed, it's formed like facing that river, and it's formed up from that valley and stuff. Right. CD vibe. And then I'm gonna run this, and then run that. So so taking the same principle of taking a sequence of numbers and creating an image out of it, there is another system. It's called L systems, and they use it to categorize planes. And you can actually sort of see that. And again, I provided almost the same prompt, which was like, oh, I discovered that L systems exist. I said, find me an archive of L systems. It found a document. It converted the formulas provided in that PDF into these drop-down items, so that when I do this here, neat stuff happens. So that's pretty cool. That's pretty cool. L systems are awesome. And with that, I think we're coming up to about 3:14, so it's going to be time for pi. There are plenty of other examples to delve into, of course. If you have any questions, please feel free to ask. Of course, this space is now a space for conversation about these and other topics, so please be open to do so. And let the vibing begin. You are now Tony Stark, empowered with Jarvis-like powers. Is Jarvis the ultimate one? It was Friday, then Jarvis, right?
It was Jarvis the original.
Oh, Jarvis was the original. Okay.
The comic Friday is actually evil AI. But
Yeah, that's true. He's taken over or something.
yeah.
Well, the Pi Day Game Jam continues all week at itch.io/jam/pi-jam, I think. So check us out there. Follow along. If you have any questions, get into the community posts there, and have a great day. And who wants some pie? We got plenty of pie options.